Assalamualaikum and hi everyone. My name is Ashleza Binti Ahmad. I'm from Faculty of Environment and Surveying from Universiti Teknologi Malaysia. So today I will show you how to do a photogrammetry data processing. So before we go further, what is photogrammetry? Photogrammetry is the art, science, and technology of acquiring information of physical object and environment to the process of recording, measurement, and interpretation of photographic image, pattern of electromagnetic energy, and other phenomena. So, in this data acquisition, before we fly the drone, we must do the flight plan. So, to create a flight plan, we can create here at DroneDeploy.com. So first of all, we must log in the account, and then we will create the project here. So, and then we put the area that we want, area of interest. Okay, for example, Universiti Teknologi Malaysia Skudai. Okay, and yeah, this is it. And then we click create project here. So this is coordinate system, and usually it uses WGS84. And then, so this is the area of interest. So to create the flight plan, we will create the manual or standard. So for the standard, okay. So first of all, this is the flight plan that will appear. So what we need to do is we just move it by the area that we want. Okay, for example, I do it like this. So this is area of interest that I choose. So next, based on the equation, we will use 65 of altitude, and then we can enhance the 3D or we can off it. Okay. So for me, I will off it, and then I will go to advanced. So in this advanced, there are automatic setting, which is we will know the front overlap and side overlap that automate. But today I want to insert it. So for front overlap, 75. So side overlap, I will choose 70. And then we have flight direction, mapping flight speed, starting waypoint, gimbal angle, which is a camera angle. Next, so in this one, I will choose. Okay, so with the parameter 3D, I will off it. We have cross 3D, obstacle avoidance. Next, for the planning camera, I will choose Phantom 4 Pro camera. Okay, so based on this, we have created the flight plan of this area of interest. So the total, the drone will take 5 minutes and 43 seconds, and it will have 70 images and using 1 battery. So that's all to do the flight plan of this area of interest. After we have collected all the images from fieldwork, we will do the data processing. So for the data processing, I will use PIX4D mapper, and I will show you step by step. So PIX4D mapper is the leading photogrammetry software for professional drone mapping. It also export digital maps and models, which are automosaic, DTM Dsm, thermal map, index map, point cloud, and also 3D textured mesh. So first of all, search PIX4D mapper and open the software. So click new project, and for the name, rename as the one we want and save to the folder. Okay, then we click next. So for the next step, we have to select the data, which is the image that we collected in the fieldwork. So we have to select all and click next. So for the next step, this is to choose the camera and all the setting, and this is coordinate system. And then for this one, we choose the 3D maps because we want to do the Dsm DTM and automodel. So this is will appear for the next step. So we choose processing option. Initial processing, we choose full, and then point and mesh. We can change the image scale, we can change the point density, and then for 3D textured match, we can choose the resolution, and for the next step, we can choose a DSM filter. So because we want to do a DSM DTM, so for the DTM, we click the geotiff, which is we want image file. And then for the method, we choose triangulation. And next, we just go through everything and click OK. So after we have done all the setting, we need to start the processing, which is we need to click start button and just wait. That's all. After we have done all the processing, we will get the output. So, and then what we need to do is we need to just insert in any GIS software such as QGIS. So this is the final result. So we have Orthophoto, we have DSM, and also DTM. So next is we need to change the color. Okay, for example, for the DSM, I will change to single band pseudocode, and then this is the result. Same one for the DTM as well. So I will just change the pseudocode color. So this is output for the DTM, and DTM is used for CD elevation. So we will make the contour elevation. For input layer, we will choose DTM, and interval, let's say I will choose 2, and then I will just click run. Alright, so I want to change the color, so I will choose the color. Okay, for example, I will choose this one. And then I want to see the elevation value. So we choose elevation and then we OK. So this is the final result for the DTM and the value of elevation as well. We also can represent DTM in 3D model. So this is the result of 3D model of DTM. The red one represents the higher elevation and the blue one represents lower elevation. So the result of this assignment, we will get Orthophoto, Digital Surface Model DSM, and also Digital Terrain Model DTM. So I guess that's all from me. Thank you.